Good afternoon, everyone. Welcome to today's webinar looking at the new gas chromatography from Agilent Technologies. I'm Ken Brady. I'm the Marketing Program Manager here in Europe for Gas Phase Solutions. We'd like to really tell a story around how we've developed our new product, what the product is, and some of the smart, connected, self-aware technologies and accessories that come with those new platforms. Agilent, as you know, are by far the dominant manufacturer of gas chromatographs. We've been the innovation leader and the market leader for some time, and it's a market that we've been in for over half a century. And over that half century, we've really changed how gas chromatographs work, and you can see from this slide, if we take a look over the last 50 years. We came into a market where there hadn't been much in the way of technological development. It really was a new technique which was not widely used. And as Hewlett-Packard, we used the Hewlett-Packard ethos and the Hewlett-Packard method of innovation to develop easier to use products. Hewlett-Packard were a company that looked at ergonomics and use of scientific instruments back in the 60s and early 70s, when it was an alien concept for most companies using everyday equipment. Agilent have continued that innovation in the Hewlett-Packard way and have really driven the innovation in ways that are demanded by our customers. Everything we do is really driven by the feedback that our users and customers give us, and nothing has changed. So you can see on this slide, we started many years ago with the 5840 GC, which was the first microprocessor controlled GC. We've had innovations like the first automatic injector. We have innovations like retention time locking, which really make things easier for our users, all the way up to 2016, when we launched the Intuvo 9000 GC. And Intuvo is a step change in what GC can do. We'll talk about that more as we go through the presentations, but Intuvo really brought us to a point where we changed GC. And Intuvo is not for everyone, but it brings a lot of usability, intelligence, connectedness that doesn't exist in scientific instruments. But really, Intuvo is the pinnacle of what we can do with GC. Intuvo, though, is not ideal for every application, and it's a step change maybe too far for most users. We were at that stage where we have all of those technologies and all of that capability. We also have our main platforms, the 7890 and the 7820 GCs, and the 7890 GC is the biggest selling GC ever made, more widely used than any GC, more flexible than any other GC. We want to replace the 7890 GC. So how do we do that? What's the roadmap for developing a new product? So you can see from the slide on this pathway that we follow, the first thing we have to do is assess our customers' needs and assess the value of the changes to a customer. We then define the scope. We design, we test, we engineer, we manufacture that new product. And then we have to work out how we support the changes to that product, and we go live and we start delivering those products to you. And really the questions we have to ask ourselves are, what do we do next? What can we do next? What's possible? What would add value to you, the user? What would be helpful? What would make your life special? What would make your life easier? And then what would make that instrument, what would make that product special enough for someone to want to have that instead of the instrument they have right now on their bench? So the first thing we have to do is ask the people who matter, and those people are you, our customers and users. We came to you. You may know that. You may not know that. You may have been part of the feedback sessions. You may have given feedback that came to steer the product development. But we get the feedback. We listen to that feedback. And what you told us was that you wanted us to improve the user experience. You wanted the instrument to be easier to install and set up, easier to use and maintain, and to make gas chromatography more practical for today's lab environment where it's really busy and downtime is a real issue. Also, you want us to prepare for the next generation of GC users. Some of our presenters on today's call are younger than others, and some of them have different levels of experience. I started working in laboratories when we didn't get to be specialists. You didn't get to work on one technique your whole life. I'm never going to be an expert in any one technique. I don't have the experience of some of our other speakers on GC. I have a broad knowledge, but I don't have the specialist techniques. I can't troubleshoot in the way that some of our other speakers today can. And we are starting to see in laboratories more and more generalists and fewer specialists. And you're asking us to make an instrument that's easier for people like me and those generalist users to use, that fits in with what they do, that's recognizable, and that can be really easy to pick up without reading a manual. The other feedback we had was that we've developed new instruments and we've brought new features to all of those new instruments. The capability of the system has grown faster than the usability, and that you have features on the systems that you never use because they're not easy to access or easy to implement. You, our customers, have asked us to close that usability gap, to make sure that the features that exist on the gas chromatograph actually can be used on the gas chromatograph without the expert knowledge that we know is now becoming more dilute in every lab. We also go out to customers routinely, and a few years ago we had a massive lab manager survey where we spoke to thousands of lab managers across the planet and asked them what they wanted in new instruments and what they needed from Agilent. And those lab managers shared their feedback, their challenges, their aspirations. And 58% of those cited business efficiency and productivity as their number one business objective. I imagine most of them have it as an objective, but 58% cited it as their most important objective. 73% of those people recognized unplanned downtime as their biggest challenge. I imagine 100% see it as a challenge, but for 3/4 of those people, it was the biggest challenge. And over half of those lab managers see staff development as their number one personal goal. So they want us to deliver instruments that are easier for the average user to use and to deliver results from. The other feedback we were given was that there are some challenges facing labs today and going into the future. And as I mentioned, the generation of super users are aging and retiring. So the skills in laboratories are declining, not because people aren't clever or aren't capable, but because everyone is a generalist. That means that the method development and troubleshooting skills are no longer easy to get hold of in every laboratory at the instrument. So people need to grow their skills, and we have to help train operators to assume those multiple responsibility roles, but deliver results in the laboratory with the instruments that are there. So there's really a need for smarter instruments with more connectivity so that we can have remote troubleshooting and remote development without having any complexity on the instrument. So where are we today? We know what we want in an instrument. We know how people's experience is. We know what the desire of the lab manager is. But things have changed since we last developed an instrument. You know, it's close to a decade since the 7890 was launched. Things have changed in that time. If we look at things we use every day, like mobile phones, you can see here how mobile phones have changed over the last 2 decades. We used to have no screens, then we had small screens and buttons, and then we had bigger screens and smaller buttons, and then we had keyboards with more buttons, and then we had the iPhone, and the iPhone changed everything. The idea of a touch screen with something that can be changed with an operating system change, and features can be brought in just by adding an icon. If we look at the things that have passed, the things that have worked, the things that failed, the things we tend to stick with and the things we embrace really are the things that are the easiest to adapt to, that give capability without complexity, and the ease of use is absolutely key. So we're in a situation where we're all used to having complex computers in our hands and pockets and desks, but we use them in a way that's simple without thinking. And it's that easy to adapt technology that really is making our lives different. And if we see how our lives are becoming different, we're in a situation today where our world is becoming far, far more connected, and the smart capability of things is increasing day by day. Most of us will have features that were science fiction 20 years ago. You know, we're living where the smart home is a real thing. Geofencing, heating and air conditioning controls are based on where your phone is. The smart car is becoming a reality. I can look at a map on my phone, and I get in my car, and my car automatically starts a sat-nav to tell me how to get there, how to avoid traffic, when I'm going to arrive, where I can get fuel. Things are changing in such a way that smart capability and the connectivity is changing our lives and making our lives far, far easier. So we're seen now as being in the fourth industrial revolution. For us here in Britain, we talk about the Industrial Revolution, and that's seen as the first industrial revolution, where mechanization, the use of steam power, burning coal and wood to create power, gave us the ability to really scale up manufacturing and have this industrial scale manufacturing. The second industrial revolution really was the onset of the production line and mass production. Henry Ford. Bringing the repeat manufacturing and the volume manufacturing that reduce costs and makes things more regular and routine. Then we had the third industrial revolution, really in the late 70s and early 80s, where computer control of those production systems meant that they could be far more efficient and things become far more easy to get hold of and lower cost. And now we're in the fourth industrial revolution, where digitally enabled Internet of Things and these digital ecosystems really are changing how we interact with things and how everything changes from the manufacturing, the development of new products to the use of those products. And we see a similar trend in what we do with gas chromatography and Agilent. We see where we are right now as our fourth GC revolution. In the 80s and 90s, we launched the 5890 GC, and the 5890 GC was a step change in technology for GC. We had control for other components, we had computer control, we had a data system, and we had floppy disk drives so we could move data around and we could move electronic methods around. Then we had, in the 2000s, the 6890 GC, and the 6890 is based on the technology we had in the 5890, but it brought things like early maintenance feedback, retention time locking, so you can transfer methods across GCs. You can get same results in different places, but with the maintenance feedback, we can see counters that tell us when it's time to change things. But there's no intelligence; it's just based on the number of uses. Then with the 7890. The 7890 and the 8890, we have more and more change, right up till today with Intuvo, where we have onboard dual-core processors, where we're measuring hundreds of different set points, and we have intelligent diagnostics and a browser interface so we can see those diagnostics remotely. And today we're looking back to those airbath ovens, the 5890, the 6890, the 7890. Today we're talking about what comes next. And those smart capabilities that we've talked about, the requirements of our lab managers and our users, and what they want and what they need, and we have to deliver those. So we've been asked to let you spend more time on what matters most. You'd ideally like instruments that are more self-aware, ideally able to self-diagnose. With the capabilities we have with the Internet of Things, we can bring an ecosystem with embedded sensors for intelligent diagnosis of problems. We have real-time processors so we can evaluate those problems real-time, and we have these smart algorithms and smart consumables that make life easier for you, that tell you when you have problems and tell you how to fix those problems. And the big surprise is we didn't bring just one of those, as you can probably tell from this slide. what I'd like to do now is hand over to a colleague of mine, Brian White. Brian is a product specialist here in the UK. Brian has many, many, many years of experience, is an expert gas chromatography user, and has been with Agilent for some time. He's been in this industry for many years and has a long history of developing intelligent solutions. And Brian's going to tell you an awful lot more about what we're bringing to the market.
Thank you, Ken. So before I start on the 8890 and the 8860, the key thing here is to look at the first GC really that's made a big, big difference in how we interact with instrumentation. So the first GCs that I used was 5880 GCs. You can see how long ago that actually was. And if you look at the 5880 all the way through the 5890 and the 6890 and the 7890, yes, their performance definitively did improve. The accuracy of the EPCs, the ability to get reproducible retention times, etc. And we got to the 7890 when really, technically, there is nothing more that you actually need from a GC. But the way that we actually interact with our instrumentation hadn't actually changed in many decades. And what was clearly needed from the new sort of range of GCs was for them to be easier to use. They needed to be smarter, so that the instrument itself would tell you it wasn't producing the right answers. And obviously in this today's world, needs to be greener really, if at all possible. So the Intuvo was developed about 2 or 3 years ago. And the reason why I'm going to start on this is some features here within the Intuvo are actually repeated on our air bath oven equivalents. Let's look at the Intuvo. The Intuvo totally is redesigned really, completely how GC is done. And what we have here is instead of an air bath oven, it's direct heating, it's a hot plate. And we have specific columns that fit the column against that hot plate. So it's an ever increasing radius, but only one column thick. Now the benefit of this is you can heat at 250 degrees C per minute throughout the whole temperature range. And clearly this is the GC that we go to where ease of use is paramount because there's no cutting of columns, no fells needed here. But additional to that, when fast analysis is needed, because if you can heat at 250 degrees C per minute and also cool from 450 to 50 degrees C in less than 3 minutes, you can see why this GC has some unique abilities. Over and above that as well, we have a disposable guard chip because this column can't be trimmed. So in traditional use of GC, where you have dirty matrix being injected, one classic way of handling that is to trim the column. Clearly in this situation we can't do that, but we have a disposable guard chip which has 0.8 of a meter of flow path within it. That being independently heated allows us to basically trap the matrix on that and then backflash from that. So there are some unique things still about the Intuvo that still needs to be of interest here. So a completely different flow path. Traditional flow path where you see normally of all GCs out there in the marketplace, you will see bits of capillary column at the base of the GC. You see fells everywhere, you see nuts everywhere. It's never, GCs don't tend to be a neat place to be. On the Intuvo flow path, then we have got rid of those nuts and fells, and we don't need to cut the columns. Obviously it's a completely different flow path, and we're making connections by basically it's click and run connections where you're deforming the metal to make it. So it's actually inherently more gas tight than you'd ever get with a fell. So here's a description of how we're actually making those connections. You see effectively it's by pushing one metal against a softer metal, the softer metal here being the guard chip, and it's a direct seal. And it's just so much easier to do, easier to train, less unplanned downtime. You know, basically, as a lab manager, that your GC is going to be working first time. Now over to another feature of the Intuvo, which is applicable now to what we're discussing primarily in this WebEx, which is the 8890 and 8860 intelligent air bath ovens, is the leak checking. So we have the latest generation of EPC, which is our 6th generation EPC module. So you can see that on the right-hand side. And whenever we do any maintenance, because the GC knows exactly how it's configured, it has the ability to do automatic leak checking predominantly. This is incredibly valuable. So when you're actually changing even something as simple as a liner and you're putting a new liner in, you know it will automatically do that leak check, and you know as an operator that as a result of you doing that maintenance, your analysis will not be impacted. In fact, it will, you know it's going to work first time, and something silly hasn't stopped you losing an over the weekend run or an overnight run. So this is about connectability. So you can connect to any of our GCs. Now, basically, with a pad or a computer, or you don't even need to be on site if you wish to do so. Each of the GCs have a dual core processor. So as long as you're allowed onto the local internet and you type in the IP address of the GC, you're logged straight in, and you're as if you are actually controlling the GC. Clearly, this can be password protected if anyone has concerns about that. But what's really, really nice here is that you can connect in, you can see what's happening. The GCs have all of their instructions on how to use them embedded within them. So if you needed to basically do any maintenance, for instance, the instructions for that are there. So here's an example of that. So you can see effectively, you go in there, you go maintenance, perform maintenance, and go inlet. And if you have here replace liner, you can see it will tell you what tools are needed. It will cool the GC down so you don't burn your fingers. It will turn off the gas supply when the areas that need to be cool are cool. It will then give you step-by-step instructions on how to do that maintenance. And then once the maintenance is done, i.e. you have now changed the liner in the situation, it will do the leak check like I've just said previously. And then effectively it now has automatically started the timer, which means that you know how many injections are done down that liner. So when you actually need to change it again. So you can set that maintenance timer, and it obviously depends on what analysis you're doing, but that maintenance timer will then tell you when the next liner should actually be changed. So here we have basically an example of all the information you have as a user at your fingertips. We have Agilent University, Agilent.com, Agilent GC Community. If we go back to Agilent University, this is a really undervalued resource. It's absolutely excellent. So please just type in Agilent University when you finish listening to this WebEx, and you will see what's there. It's instructions on technique. It's not really primarily on our instrumentation as such. It's more about how to use a GC and how to optimize your method. So please go and look at that. So when it comes to instrumentation, and you've got instrumentation in your lab, and yes, occasionally it will go wrong. And when it goes wrong, you're left with having to get it fixed. So what you need to do is you actually try and work out what's actually wrong with the instrument, and you then phone up Agilent or your instrument supplier, and you basically tell them what you think is wrong. They will evaluate your evaluation, your interpretation of what's wrong, and they will then send out an engineer, and hopefully that engineer will turn up with the right parts. Clearly, that's not really 21st century as far as instrumentation is concerned. If you had a car go wrong, you wouldn't nowadays expect basically the mechanic to be scratching their head and trying part A to part Z. What you expect to happen is for the car computer to tell them, the mechanic, exactly what's wrong, so they know exactly what part to fix. Why shouldn't you expect that, therefore, from your instrumentation in the laboratory? With the new range of GCs, whether it be the Intuvo or the 8860 or the 8890, you have those dual-core processors on board, and that means they're monitoring all the settings. So what you can actually do is basically you've got a health report that can be produced from any of these GCs. And this will either be a proof that the GC is working absolutely perfectly, or should there be a problem, then you can actually download that health report onto a USB and email that to Agilent, and we know exactly what's wrong with your instrument, which means that you're going to get first-time fixes. This speeds up everything for you, the user, and also for us, the supplier of the instrumentation. It's just basically a much more modern way of going about fixing instrumentation. And what we have also is on board the GC is all about installation and familiarization, all about compliance service and education. We have all the training you need actually on the GC. So when you did a firmware upgrade on the 7890, for instance, this would be done in 5 minutes because there's not an awful lot that's going across. But when you do a firmware upgrade on our new instrumentation, then that can take up to an hour because the amount of information that's going across to the computer on board the GCs is quite significant. It's got all that training, all the pictures, all the videos, etc., all there, actually embedded on the GC. So, if you wanted to develop a new air bath oven, because ultimately some people need the flexibility of an air bath oven, and the Intuvo would not be basically the right GC for everybody, where do we start? Well, what we need then is we don't want to sacrifice the performance of the 7890 as far as repeatable heating is concerned. That oven is well recognized out there as being given excellent repeatable heating as given by the retention time stability that all our users are getting. But we also don't want to keep all of the intelligence and all the leak checking of the Intuvo. So if we combine the two in your mind, this is where we will actually end up with, as far as the 8860 and 8890 are concerned, which are clearly those two blue sheets there. So if you look at the 8860 GC, which is our mid-range offering, what we have here is advanced proven technology. I mean by that is everything that's on the Intuvo for the connected abilities and being able to connect in from outside. It's also the rugged and reliability from the 7890. And the way to actually position the 8860 is where core routine applicability meets ease of use. And it is the next powerful generation of electronic architecture. So as already said before, it's got dual core processor on board for real-time checking and the connection. The 6th generation EPC that I mentioned with the leak checking from the Intuvo, it supports 2 inlets, which can be a mixture of split-splitters packed or cool-on column, and 3 detectors at a time. So you can have 3 detectors on this GC, a mixture of FIDs, TCDs, ECDs, FPDs, NPDs, and MSD. And should you be doing gas sampling, you can have up to 3 gas sampling valves and 6 heated zones. So the 8860, this is what the touchscreen looks like. It's very similar in its appearance to the Intuvo, so it's a color touchscreen interface. It's like you get on your phones, so it's incredibly responsive. It's not squidgy, it's a proper touchscreen. On the top there, you see a flow path configuration, and it tells you what the set points are and what the actuals are. And next, if you go down from there, you see the real-time results, a chromatographic display, and then there's also status information should you want to monitor any particular temperature setting. So we have the diagnostic tests, so you've got inlet testing. So this is really the key part of the whole GCs, to be fair, the new GCs. So if you're using it, it would tell you whether you can do a leak and restriction test. So this means not only as a result of putting a new column in, there isn't a leak, but as a result of putting a new column in, there's still flow. That's where the restriction test comes in. You've got a pressure decay test, split vent restriction test. So you're actually, in the past, you'd have a problem with your tubing from your split vent getting blocked, and you didn't know that until you undid it and checked whether there was dirt in there. Now the actual instrument would test and would tell you there's a problem. And if you look at the FID as well, FID jets were being changed when they didn't need to be. Here we have an FID jet restriction test, and also we've got a leakage current test as well. So these are all very new features that is unique to these new intelligent instrumentation. So we have guided troubleshooting. So should there be an issue on the GC, it will tell you exactly what's happening. So you get an inlet pressure shutdown, nothing new there, other GCs are doing that, but however, it will tell you if the system is unstable, if there's installation inconsistencies, if there's issues with the tray firmware, if there's thermal faults, configuration faults. This GC is intelligent. It has got that core processor on board. So as far as the user interface is concerned, you've got diagnostics, troubleshooting, training, and help. And the best way to actually get that, to be fair, if you see the picture on the right-hand side, that is a big touchscreen tablet. You can connect to the GC, so if you wanted to actually see a bigger screen than what's actually on this GC, you can just connect a tablet to it, type in the IP address, and off you go, and you've got all that information on a bigger screen. This is a really nice way of actually using the AG8. Not everybody needs to have a computer next to their instrumentation. So in the past, every instrument had a computer next to them for controlling the GC, for integrating, for producing numbers effectively, calibrating and producing numbers. If we have a computer on board with sufficient memory to store many years worth of data, then clearly one option is to actually put the integration and calibration onto the GC itself. And if we do that, then you can actually then control the GC, integrate and produce numbers from the instrument, which is ultimately why you bought the GC, from any particularly useful this in academia situations where you have many users, and you may not want a computer next board. They just basically want to do a simple analysis, and they just want to connect in with their own computer, do all the calculation, produce the report, and take that report away with them. So this is just an option, and we call it DA Express. Clearly we have other options which are computer-based for doing all of the software and all the integration and calibration. But this is just a novel option that you have now with these new intelligent GCs, and only really on the 8860 GC. This is what it looks like. You can't really see too much, but if you go across the top there, we have methods, and then another tab is sequences, then another tab is DA Express, and within DA Express is where you get the calibration and the analysis. And like I say, you can store unlimited methods and sequences, and it's all served up within a browser interface. So that's the 8860, but if we now look at the 8890, this is the premium GC out there on the market now. When you are developing any solution to go on any GC, the first GC you make sure that your solution works on will be an Agilent GC because of our position in the marketplace. And the 8890 interacts with just about any GC thing you want to consider. There are no limitations to this instrumentation. So what we have is powerful next generation architecture, similar to the 8860, but what you can see there is a bigger screen. This is a 7-inch color touch display. We have Spark connected functionality, the full suite of inlets, and you can have 6 valves, 8 heated zones. It's got the next generation EPC, again from the Intuvo. And what you will notice there is a smart key. So below the touchscreen, there's an area there. And remember the smart keys from the Intuvo, where they actually, when you plug in a column, it tells the GC exactly what the column is, and what the dimensions are, what the top temperature is. Well, this is where you can buy columns now which are 8890 applicable, and you can basically have those smart keys, pull it into the GC, and the GC knows exactly what's happening. So the 8890 GC has, again, it's a 7-inch color screen where you can see the configuration, status, methods, sequence, troubleshooting, diagnostics, and help. It's very similar to the 8860, but obviously on a bigger screen. And real-time chromatographic evaluation, blank evaluation, detector evaluation, and those smart keys, which are unique to now to the Intuvo and to the 8890. So let's look into the browser interface for all of these GCs in a little bit more detail. So here we have on the left-hand side an example of status, and this is basically a dual channel system, quite clearly, with an FID and an NPD, and you can see the temperatures and the flow rates that are currently happening on the instrumentation. And then if you go on the right-hand side, this is you can actually put methods straight into the GC should you require it, or this would be obviously if you don't have a data system next to the instrument or a LIM system, etc. But still. And here we are. If you want to actually run a sequence from the GC, you can see you can cut and paste lines. This is not like in the past where you basically start on line 1, file 1 to file 9 using method X. Now you can actually interact with the GC directly, just as you would do from a data system should you wish to do it this way. And you can inject from file 9 using method A and from file 15 using method B, for instance, total flexibility, cut and paste and copy on all those lines. And then maintenance on the right-hand side. This is really where I mentioned earlier where the GC will automatically start the timer should you do any maintenance through the system. By that I mean scepter, liners, changing columns, a number of things. And as an experienced user in the lab, you'll know how many injections you can get down that system before before any of those should be changed. And so therefore what we have here is incorporated a maintenance timer, which will highlight to you a more inexperienced user when, let's say, a liner should be changed, which will basically mean that will change before you get a problem, which is what we're trying to achieve here, is more uptime and less issues diagnosing what's gone wrong. So as far as diagnostics is concerned, this diagnostics page on the left-hand side is always checking its systems, and it can self-diagnose what's actually wrong with it. And here on the right-hand side, this is an example of a help page. And here's a wealth of information at your fingertips, including tutorials, troubleshooting. Much of this is actually embedded within the GC. So you can go in there and it will tell you how to use itself. So how do we position our 3 GCs to you, the user? So the best way of looking at this is the Intuvo, which would be our first really intelligent GC that we've launched into the marketplace a couple of years ago now, is where ultimate ease of use meets the highest productivity, especially if you're considered with mass spec as well. I would add to that it is our go-to instrument when we want to do extremely fast chromatography. The 8860 is an incredibly good performing, excellent instrument really, where core routine applicability meets ease of use. And then if you want total flexibility and performance, that's where the 8890 sits in.